So does it make for you? So please give me like reaction. Okay. So we're also we're gonna do everything just after the midterm. So we start from department like exam archive. So let's start with this like the work problem. So can you see my screen? Thank you. So this is like a vat is shape shown below. The vertical end is like below by the y equals x to the squared. And let's just use the 5 feet. Height is 4 feet. So here's 4 feet. And now now there are some O's inside there. All wait for like here's the weight. Set up then do not compute any integral just to work. Hi. So welcome. We are just gonna do some reviews. Now we are working on like department archive. So here's the work. So for this is so like also this we need to find the volume of this like all like oil because like in order to pump all the oils out of here, the first is compute the volume. So draw like these lines here. So here y equals to x to the squared. Then we here's the 5 and just here's gonna be 4 and then we just here's the height is 3. So the upper bound gonna be from like a 3 to like a 0. In this cases, we're just gonna also compute the volume. Then and we just put like a density here because like because here's how they just to solve the problem because I'm not gonna look at it. So I'm just so here's like the thickness here. So it's like each like is slices of the water and like the volume made is in this case because it is the height, so it's a y bound. So we need to use like a y as a variable. So this is in terms of x. Now we are gonna to write the function as in terms of y. So x to y to the 1/2. So x it is gonna be like x equal to a square root of y. So this is a function that is the curve of this. Here's one slice of x. And what you have is here is delta y because like Jesus problem is pretty hard for me. So like so I will record this the whole videos and then post on the Discord. So all the problem they're from like department archive or like Andrew Lovelace archive or from April JKL's archive. So I will record the whole thing and I will drop the recording by the end of the day post on the Discord. So, as for the weight, it is 50 pounds per. So the weight is 50 pounds per feet. Just like, and we have this. The license is like the width, and here's a 5 feet. Is this like the width this way, and for each thickness is here. It's just the. But here's the width. And for pound is and for pound then you get is like 500 like vi. For now we have the volume is 2 squared y and then we get this is okay. Here's a here this is the 5 feet, so you time this by 5, so 5 by width and this is like delta y and this will be the volume and then it's like the weight is gonna be 50 and times 10 and then times like dy is function itself, and then it's like delta y, and the distance being lifted, so the total weight height is a 4 feet. So just like now you have 3. So like the height can be y, so the height can be 4 minus y. So this is the height of the all that being pumped out, and then you just have the integral. It's just 500, or like function here. 4 minus y, it is the height. So does this make sense, or do you need more explanation? Because I look actually because like they have like a visual here, because it's hard for me just to do everything without like any like the diagram or whatever it is. So this is one of the so this is the pumping problem. So are you good? Please give me a reaction if you feel good to move on like next question, or ask me any other thing you want to ask. Sounds good. Okay, I think I'm just gonna so I'm just gonna do some like the concept review for like for work. Because like this may be kind of a like I think it just better. So it's like you just so there's like a work. And so work is a force and the distance. So they're like a two type of the problem. So you have one type. It is I can do this like this argument. The first type it is like it is like a leaky bucket. So if you see any problem, it's like okay, you have a bucket and it's leaking out of water. Then use this type of like leaky bucket. And the force is like the size of the function is fxi, and the distance is delta x, and the work is like the the function that from A to B, which like the upper bound and lower bound, or it's like the volume of like, or it's the volume of like specific thing. If it's leaking at a constant rate, then it is like a linear function. Because linear functions have a constant like a slope, or the forces already have it, so just the effect is a force. Then you just put force and distance in one integral, then just evaluate the integral. That is the work. And then for like if you have like a so if you see a problem, it is just like a lifting a chain, or like pumping out of water. Then just use this kind of a thing. So the force is like a horizontal slice, and it's like the density and the volume of the slice, and the distance will be that how far or how far did you vertically or horizontally stretch like this thing, and the k it is the density or it's like the force per distance. So for here you already also typically it's like, and then here the force, and for the distance it is like the total distance you move, and the work is just b to like a 0. There's and this lower bound x times like the k, then just integral. And then for pumping like the thing, then you define the k, the density, then just a force is just the density and the volume. And so you need to find like the volume equation here. And distance is like distance moved by the slices. So it's from like a b upper bound to like a 0. This is like all the distance. And then it's like pumping from A, it is like one was like a height of what's a height of the liquid, and just minus y, then just put force and the distance together and then do like the integration. So the problem we just did is a pumping problem. So if you see like a pumping, it's like kind of vertical. The pumping always use dy to integrate. So this is the only thing that you can just recognize immediately. So you have a work problem. So does this make more sense? Because like for today, so we're gonna spend most of the time on like how to do lots of different how to do lots of like the lots of like the integrals, because that is most part on this midterm. So are we all good? So okay, sounds great. So about the average value, I'm not going to spend most of the time on it. So we're gonna back to the exam archive. So we're gonna solve like a lots of integrals tonight. And so for this, what do we do first? So for this, it's like e to the 4t plus 3 and e to the 2t. So the first is like by Hubbard rule, e to the 2t times e to the 2t, it is e to the 4t. So we can sub that u equals to e to the 2t. Then this is going to be like a square, because like for this, you would know that the 1 over x squared plus a squared is a 1 over a inverse tangent over x over a. Then we can do u sub and do kind of like inverse tangent stuff. So it's e to the 2t is the u sub, just to change the upper bound and lower bound. And that's what to do. So lower bound should be e. 2 here should be 1. And then it is gonna be 1 over radical 3 arctangent of like x over radical 3, or it's like whatever it is, to just do the integral. And then e2, when do the like u substitution, this should be canceled out. So and then you should be have like 1 over e to the 2t squared plus 3. Okay, so much. Okay, so let's just do the u sub, and then just do the computation. So does this make sense to you? So please give me a reaction if you think that it does make sense. Okay, so I will re-explain the thing. So here's E4t, this is E2t. And by power rule, E2t times E2t is e to the 4t. And then back to the integration formula here, that x squared plus a squared is 1 over a inverse tangent of x over a. So back to the integral here again. What I have it here. So you can see this is going to be e to the 2t, it is x to the squared. And the a squared h is going to be a is going to be radical 3. So we do the u sub, and you make it like this. Because it's like radical, so and then there's like a list. So what need to u and then the u sub. and they make it like this, then just evaluating it. Now, did it make more sense to you? For part B, that's a partial fraction. Then we need to set the bottom can factor as x times x squared plus 5. Then we set 25 over x. Actually, it could be plus 5x equal to a over x plus plus bx plus c over x squared plus 5. Then we find a and b, then do integration. So here x, so just a factor x out, then you get is x times x squared plus 5. So this is like irreducible linear. Though this is irreducible quadratic, they set this part 25 over x cubed plus 5x equal to a over x plus bx plus c over x squared plus 5. Then just multiply and then find a and b. Then do the integral. So does this make sense to you? Okay. So next, so we're gonna more integral here. So for this, it's just the tricks by completing the square. So we write it's gonna be like a negative x squared minus 4x. Actually, if you put a parenthesis here, you have negative x squared and put a negative sign ahead of it. So I'm gonna pull out just to see because it's better for me to just say everything here. And then did you see it's like a negative x squared plus 4x minus 4x? So did you see this? And you can make it like a negative x squared minus plus 4x and plus 4. Then like everything here, you get give me like a negative x minus 2 is negative, then minus 4 and minus 5. Then you get this like a 9 minus x to the squared, and then use the trig sub that wait. Okay, so I am I will see if I can do some painting on the Zoom. I will see. Because okay, just let me Google it, okay? So how to click the pencil shape on it. So I needed to search this history. But I am I think is I'm okay. So I'm just gonna write down like a Word document. Then I'm just to share the Word document to you. This may be like a better idea because I don't want to waste like a 20 minutes on find how to just do painting on Zoom. So does this work too? I did the painting before, so Just gonna be tricks up. So the integral we have, it is 5 minus 4x minus x to minus x to x squared. So can you see my Word document or no? Okay, I will change the setting here. I will reshare. Now you can see it, right? Yep. So we have this integral. It is 5 minus 4x minus x squared. 5 minus 4x minus x squared dx. So if you ever see, if you see a quadratic equation like this, like x squared plus bx plus c, use the completing the square and x up. So for this integral, and what we have it is negative x squared plus 4x, I mean plus 4. This is the thing, and we just minus 4 plus 5. Okay, I think we should. Okay, I need to do this. 5 is equal to be like a negative, then gonna be x squared plus 4x minus 4, and we have it this. Wait, this is add. We have gonna be negative 4, negative 5. And then what we have it is like the negative. We have gonna be x plus 2 to like the square root minus 9. Then what we have it's gonna be 9 minus x plus 2 to the squared. So this is like a squared minus x to the squared. Then we set, then we apply the trig sub. We set x plus 2 equal to 3 sign of it data dx, well, because 2 it doesn't matter, so just the cosine of a theta d theta. And then we write the integral of Vs 9 minus Then we rewrite the integral as 9 minus 9 cosine x to the squared sine x to the squared of theta then we have is this. Then just put this as a 9 times the 1 minus sine squared is 9 cosine x to the square. So I'm gonna write it out this. So this is gonna be 9 well, I do apologize for like the speed because typing mathematical on here it is really hard for me. So I do hope you just appreciate like the thing. Why is this so? Okay, now we have this, and then we just then just integrate it again. So we have gonna be 3 cosine of x, and it's like 3 cosine of x is 9 cosine x to the squared. So back to this. Then write this as half angle identity. 9 is a constant, so we pull a 9 out of here. So the half angle identity is gonna be 1/2 maybe 1 plus cosine of 2 theta. Then dx. Because this is an indefinite integral, that means to rewrite that we need to draw a triangle here. So we need to draw a triangle here. So for this triangle here, so this is an angle theta. So I'm just gonna the shape field, it is no field. So it's this triangle here, and I can see here's the angle, and the sine of x is x plus 2 over 3. It is sine of x. And then we just x plus 2. It is this side gonna be x plus 2. Here again gonna be 3, gonna be this side. Now you can see this, and this mass, it is this side. So does this make sense to you? Okay, so I'm gonna try not to go very fast because I want to make sure that you understand everything uh that what I'm talking about. So this is what I just want to make sure. Then we have this mess. Yep. And then just evaluate the integral, just rewrite this and like this theta is going to be arc sine of the side. So if theta is the arc sine, then it is arc sine over this over this. That is like the angle. Come on. So the data here will be just to find angle is arc sine. It's going to be x. So this will be arc sine x plus c over 3. Then that's going to be like the whole thing after solving those bunch of mess. So does that make sense to you? So are we good to move on to the next problem? Then let's do part A. This indefinite integral. Another trig integral. Another trig sub. Just give me some time so I can put that integral here. So it's going to be this x plus 4 plus 1. So it's going to be plus 1. Yes. There's the trig sub. Just the solar trig identity here. So if you ever see just like a squared plus x squared, there is a tangent. So just the subtangent out here, because x squared, because tangent is square of x plus 1, it is equal to secant squared, right? So what? Wait. Okay, now found it. For this integral, we also need to use the tricks of. So don't worry. So this whole document, after done this review, I will scan as a PDF, I will send along with the recording together on the Discord. So you guys can just watch it also afterward if you don't understand right now and ask me any questions. X is a tangent of x is a tangent of theta. If I just copy theta sign here, dx it is Okay, I need to change the margin. Dx it is secant squared of data. Then we rewrite the integral here. Then we write the integral here. So we have, because this is an indefinite integral, so this is an indefinite integral, so you don't need to change the bound or so whatever thing is. Then we have this tangent of x, then we have it's gonna be tangent to 4. Theta. The bottom is gonna be you're gonna be this mass here. So 7, just keep it. So x squared gonna be tangent x squared plus 1 is gonna be so for indefinite integral, it's just this integral sign, and there's no number on there. So if there's a number on this integral sign, then it's a definite integral. So does this answer your question? So we just still needed to write this out here. Theta plus 1. This 7. This here. We continue to just to rewrite this integral, just to write them as easy as possible. So tangent of 4. Gonna be secant of 7. And it's like a square root. So we're just still gonna write this out as secant like square to the 7, and we just so this is just gonna be secant of 7. Yes, gonna be. So this is gonna be secant of squared. Then it's like a 2 power 2 canceled out. So it is still secant of 7. So this is gonna be like this. So gonna be the secant of a 9 theta. And then you have like a secant square of theta, then theta. So here's like the radical is 2. So if you factor this out, it's gonna be 9 minus 2 to the secant of 7. So does this make sense to you?
Yeah, I asked her, we will not, we don't have to know. Okay, I'm figuring it out, but yeah, I asked her like, okay, like this. Like we don't need to.
Gonna be tangent. Oh god, sorry.
She said
it's gonna be secant. So for every single function that are factored out of a radical, they power minus by 2. So the 7 is going to be 9 minus 2 because we factored out a radical here. and then just and probably is not 9/2 because we just yeah. So he just saying that it is very important to know that. And then we have taking in data, the data. We can just cancel the thing, just rewrite the integral. The 7 is gonna be 5, so this is gonna be tangent of 4 and it's secant over 5.
I want to go over all the stuff that possibly makes sense. I want to feel good. Yeah. Yeah. That's kind of like, yeah.
And then it writes like tangent and then you should trick identity here. And then what they have is gonna be so we write a tangent of a 4, it is like gonna be tangent is sine over cosine, so we write as sine over 4 to the theta over cosine over 4 to theta. Here, this is gonna be tangent over 4. We have 1 over secant of 5 is cosine to the power of 5.
I don't know what's going
So does this integral look a lot more easier? Then use the use of, and then and then just then just make sure it's like, and then just and then you're just gonna be sorry. Cosine of 1.
So like it's the first number and then always
The use of. But this is a definite integral, so we need to rewrite the tangent of x. Always to treat the tangent as x over 1. Just then this is x. We just use this triangle here again.
yeah, exactly.
Come on.
That was
Theta here, x over 1 is a tangent. So here's the x, here's the 1, and this is x over the plus 1.
the first thing, if I know this stuff is done.
I'm then this is the integral x over plus 1. So this doesn't make sense to you, and then just once you've done the integral, and then just put what they have on there, then that's all for this integral. Okay, the same exam, 1B, short 3 is another this is an integration by part. So we have is u du. So when choosing the variable u, always make sure that u is differentiable. So always make sure that you know what is u and du immediately. So if you have a thing of, so if you have like a natural log, then use u equal, then use u equal to like ln x, because the du is just 1 over x. So does this make sense to you?
Oh, okay. So the theorem is that water is strictly for L2 and only if
So the part 2 of the integration, that is this integral.
yeah. I mean, this is the kind of like the statement. Yeah. Okay.
It's a definite integral. While when doing integration by part, you do not need to change the bound unless you need to use substitution. So and then just do not change the bound unless thing it does need to. So for this one, is inverse tangent. So if you ever see like an inverse tangent, inverse trig, then they just set u equal to the inverse trig, because you know what is the derivative of the inverse trig, right? Because that would be a lot more easier. So this time we set u equal to arctangent. du it is 1 over 1 plus x to the squared dx. Then dv it is dx. Then v it is x. Then we do the integration by parts. And which is a uv. So this is a definite integral. So we times uv x arctangent. So we have this integral here. It is equal to x and arctangent. Going to be x and the arctangent of x, 1 and a 0, minus v du. V du, it is x over 1 plus x squared over dx. This is integration. For this one, then you need to use up. Then this one you definitely need to use up. For this one, then you sub change the bound, then you get the answer. So does this make sense to you?
something about absolute.
So we'll move on to the next question.
Yeah. This is for the graph.
Next question. So I'm just gonna. It's gonna be in this exam. So it's gonna be it can be like it's gonna be like Nishofer exam fall 2016 question 4A.
Oh, okay.
This is a trig integral.
Okay. They're risk averse.
So it's have like a tangent of 4 pi over 3 to like a 0. So this is definite integral. For this time, it's like a tangent have the even power. Then for even power tangent,
That means, like, if you look at what we
then we just rewrite them as secant y. It's like the secant minus. Then we rewrite as like, so the tangent for it is a tangent square and a square. So the trick is to rewrite the integral with known trigonometric identities. So tangent power of 4 of x. It is this.
risk averse.
Yeah. So first thing just is like to write this, and it's like what is a tangent square? Then just this would be a lot more easier. And then for this, it's gonna be a lot more, and then just rewriting rule, and then you need to use for now. You just to keep writing the integral.
See how that would, instead of getting to that next third one, that's getting that one, getting that average of that. And then a straight line.
So tangent is just, or tangent is like a secant squared minus 1. And then you just
So the expected value is same.
then just expand this, and then just to do then just to do, and then just do all like a u sub. Then we just rewrite the integral as upper bound. It just still remain the same. It's a pi over 3 and a 0. Secant of 4. There's like Okay, here gonna be like the trick here. So like we have this secant of square, so we just rewrite like the 1 plus tangent is like this secant, so we just write okay, gonna be secant of 4 minus 2 secant squared.
The utility of the expected value in by itself is looking at the money. Of course,
Minus plus 1 then dx.
A risk-averse individual.
Let me just like the part is on this. The secant of 4. For this one, just to rewrite it again. So secant squared is 1 plus tangent of squared. So we write this as 1 plus tangent to the squared. Secant squared of x. Here, if we use u equals the tangent of x, the du is a secant to the squared, then this is cancelled. Then the integral will be much more easier. For this, just the tangent of x, then just for this. Also, the trick part is on this. The power to 4. Then we just step back to this integral here again. We probably need to use, then just do the u sub here. I'm gonna copy down this mess here. Minus 2. It's gonna be this mess and a 0 and secant squared of x dx plus so does this make sense to you? Then just use the u the tangent of x, then just here just change the bound, then this will be cancelled out, then get a 1 plus u to the squared, then do computation. So does this make sense to you? No. I need to check the message, see if I missed something. So use substitution for the first integral and compute. Then it's like we went to trick integral, integration by part. Let's make sound like a partial fractions. So you caveat, I'm gonna go over some partial fraction questions because that's also gonna be on the exam.
And then so let's take what the average of is, right?
It's the same exam, but it's question 5B. So gonna the nature of 16 question 5B, it is partial fraction.
Let's say we're doing
fraction here. The integral it is this.
this case, you can plug in $50 here as well. And then you plug in half.
So this one just the factor x squared out of the bottom, then rewrite the partial fraction decomposition.
And then this is even state presence.
Just factor the denominator and do partial fraction decomposition. Then just integration, just to set them equal. So what we should do is
What is the maximum
I have 4 I square backed it out, it's gonna be x minus 1 is equal to a over x plus b over x is wait, because this is repeat the linear. Well, so this is repeat the linear, so plus cx minus 1. Do a cross multiply, then just set them equal. Just to set on 4 equal to a, gonna be x minus 1 times x, and plus b, x minus 1 plus c x squared. Then you're gonna have this 4 equal gonna be ax squared. So gonna be, so the rewrite is gonna be like a 0x squared plus a 0x plus 4. Then a plus c coefficient is gonna be x squared. We have a gonna be minus ax plus bx. Gonna be plus b minus a x plus wait, it could be minus b. This solve system of linear equation to find out what is a, the b, the c. Then do the integration. So the b gonna be -4, then a is also gonna be -4, c is 4. So I just got this. So just to make sure that I'm right? So b it is -4, a it is -4, c is 4. So for this, the whole mass is gonna be turned to a this. Minus x squared x is equal to the integral of a is -4 over x plus b also is -4 x squared plus c is 4. We can write this as yep. So does this make sense to you? I'm not gonna do the rest of computation because that's just a basic integration here. So more partial fractions. More partial fractions. Shockery, winter 2020. Okay, it is back to Shockery, winter 2020, by discussion 2. This is a 5 integral here. Oh, wait. 3, 4, 5, 6. Okay, I apologize. I apologize for like a numbering because I don't know what happened to me today. So it's just Valkyrie win 2020 is question 2 is gonna be partial fraction. So for this integral, it looks like it is just cancel the factor out. But let's do this partial fraction. This is gonna be x to the plus 1. Gonna be x to the cubic plus x to the squared. Just to factor the denominator. Factor the denominator. Oh God, I apologize again. I think I don't need this. I just do the whole thing equal to this. Gonna back to x squared out of here. X plus 1 is again, it's the same process, but I haven't typed it out. So it's gonna be a over x plus b to the x to the squared. So this is repeat the linear. Plus c over x plus 1. No. Cross multiply.
Oh, okay. So that's
Just to set this
relative to
so x squared plus a 0x plus 1. So if you're just missing the x or it's a missing x, or write a 0 in front of it. So make easier to compute a, b, c, the constant. So does this make sense to you? Just the cross multiply plus c. Yep. X to the squared. And we have this again on. So I just try to read just my mouse because like my ear feels pain a little bit after being the whole day long. So
That's fine. It's fine.
I'm gonna x squared, so it's a plus c equals to 1 this time. A x plus bx, so it's a plus b. X plus is like b. So b is 1, then a is -1, then c is 1. B it is -1 or 1. A it is -1. C is 1. So please let me know if I make any mistake. Or I'm doing good. Sounds great. This is the messy integral. It is gonna be 1 over x. Since this is gonna be -1, so just a minus 1 to the x to the squared. So if you see like a negative constant on the bottom, just write the negative sign in. Let's just in here, so to make it easier to just see it. Then plus the c is going to be 1 or x plus 1. Do use up, do the like everything, just getting through it done. So does this make sense to you? Okay. Okay. So what do you want to work on next? Want to work on like the approximation, improper integral, or trig sub, or so whatever sub is. So please put on a chat so we can just work on it. You have 45 minutes. So if you want more partial fraction, then put 1 on the chat. Trig sub, trig integral, put 2, and by part to 3, then or it's like approximation, put 4, improper integration, put 5, please. Okay, improper integral. Okay, let me find a problem.
Oh, it's a wonder who figured it out. Well, clearly the understanding. That's the person.
Let's do is initial for spring 2016 question 4. So number 7 gonna be like niche for spring 16 question 4 is improper integral. Let me check them. I need to put my charger on. Because it's gonna power off soon. So. Okay, I'm back on soon. Okay. Okay, back to it. For the integral, gonna be got it wrong. Infinity and a 0 gonna be 1 over e to the x plus 1 dx.
Oh yeah, kids are not really used. What if we go? They're like, what?
It's
I'm not really used, but
this integral here.
and then you just solve it.
So for this one, it's like we view it as a limit format. And the limit b approaches infinity. This is like infinity out of bound. So this is just infinity. I think this should be type 2 or type 1 or so whatever it is. God. So upper bound it is approaches infinity here. They have this e to x plus 1. Well,
Oh yeah. So they
okay. So just so this one is like we might gonna do a U sub here. Then we might need to do like a U sub. U substitution. U substitution method. U equals to e to the x plus 1. EU it is ex dx equals to u minus 1 dx because ex is u minus 1 dx. Then change the bound after the u sub. So u gonna be equals to e to a 0, so 1 for 1 equals to 2. The 2 is the lower bound. Upper bound is another the upper bound because we don't know what is the exact number is, so we set them as a constant c. So does it make sense too? Because we need to change the bound.
so then the very
Always change the bound for definite integral. Note that improper integrals are definite integral. Okay, then just so you can still see on my screen, right? after the u sub, we have is a c as upper bound, 2 as lower bound. We have going to be 1 over u times going to be 1 going to be u minus 1 du. And then we just minus and plus here, we just wait, then just do like the thing here, we just do it, do like you do like the or like the integrals here. I forgot this, like limit c approaches infinity here. Why would then we back to this the step. And then just we just do more like the integration here because since we just like to add a sign here, we just so integration here, we just have this like a limit the integral c and the 2. So just so if you do like the use of you can just like say again we have it's going to be negative 1 over plus. So here we need a kind of like a partial fraction here. So by partial fraction will be obtained it's going to be negative 1 over. So like the thing need to do a partial fraction decomposition. So I'm just not going to do the partial fraction here, but I'm just kind of just doing it on my own. Just added right out to the whole thing here. Then it's okay. So do you still want me to write out the partial fraction decomposition, or just skip it? Then it's gonna be 1 over u minus 1. Then du, the integration. I need to check my Discord. Okay, it's gonna be like on the limit. It is still here. It's not over yet. So we have is this. Give you like give me like a negative natural log of u. Make sure to put the absolute sign here because plus like a natural log u minus 1. C and the 2. Just evaluate the integral. For this we get just like, and then we get it's like gonna be like a natural log of 2 minus natural log of 1. So it's gonna be like a natural log of 2 minus natural log of 1. It's a natural log of 2. So does this make sense to you? Okay. So do you want to do like another improper integral, or we do something easier? Because it just toward the end of last, so it's like a last 10 minutes. So do you want to do something easier or another improper integral? Last problem. Yeah. So I would do another improper integral. But this is going to be the last question I'm going to go over for today. So if you want to ask extra thing, that then let me know that you want to do anything. So in the exam, I'm just going to do the Ultra Winter 2016 to be the last one. So Ultra Winter 2016, question number 6. Improper integral. Because I need to end by, because I need to end early because today, guys, what happened? I was in Odegaard. Well, somebody just like stole my jacket. So I need to buy a jacket later because it's too cold for me. And I just was in Odegaard. Well, I later found out that my jacket was like a missing. I just don't know how. I'm just doing all my homework. I'm going to take the jacket out of under my eye. Well, next time I'm just gonna wear it. Or for next time, I'm just not gonna take it off. Since if I wear it, that they can't just drag my person out of the seat, right? So this is gonna be a discontinuity in the bound. Plus these sine squared of x. Dx. Okay, so for this one, we need to use the comparison test. Of this, so I'm not sure did the professor talked about this, but like comparison test for like improper integral. I saw this like a method appear on the exam before. Okay, so since you're not sure, so I'm gonna introduce like the comparison test for improper integral. So with this one, it is just hard just to read because like the ex sine of x to the squared, and you don't want to do a lot of like a messy integration by part. Then we just need to do a comparison test because there's not x, not all the form of it, and you don't want to do like the two integration by part, right? Then we just do the comparison test. So for unlike from so just between the bound, So between interval, so power e to the x, it's always greater or larger than 1 because e to the 0 is just 1. Then from 5 it's just e to the 5. Then it's always greater than 1. While this function, the sine of x, it is always positive. Always greater or larger than a 0 on this interval. So we can just do, then we can say that, then we can say square root of e to the x plus plus the sine squared of x, it is larger or greater 1 over x to the squared. This is a comparison test. And then evaluate the integral. Five and a 0 gonna be 1 over x to the squared. We set them in t equal to like a 0 from the right side because just infinity just add the bound, so they're gonna be either type 1 or type 2. Right? The limit as t, we set them as a number. Gonna be 1 over x to the squared dx just evaluate the integral. I just forgot this. Apologize again for just a missing element here. Evaluate the integral. Then what you have is gonna be like a limit. T approaches a 0 from the right side because like it just in between the bound approaches like a 0 because it's all positive. That's why it is the right side. So does it make sense to you? So if this is a -5, then just put like a t from coming from like a -5. So also from the right side. So gonna be negative. So this is just gonna be negative 1 over x. We have 5 over t. There's like it's like the limit, just still the limit of just like computation. We have gonna be like a negative 1 over 5. Gonna be like a negative 1 over 5. Minus goes to positive. So gonna be 1 over t. So as t goes to 0, just goes to infinity here. So the whole thing goes to infinity. So the improper integral diverge. So does this make sense to you? I think that's probably gonna be all that. Uh,
Oh, yeah, yeah. Minus that.
I think that would be like all the content that I need to go over tonight. So if you have any like the questions, please let me know. There's our 8 integral I just walked through. I've scanned this as a PDF and sent in the Discord, and I've just sent this a recording to to the Discord. So for the last 8 minutes, so do you have any other just like the questions you want to ask? Because 8 minutes we can still 8 minutes we can go over like a kind of easier problem. Or do you want to just ask anything? So you have tonight and thank you so much. So you have tonight, Tuesday, and Wednesday. So if you have any kind of like web design homework that you have not finished yet, just to work on the web design and just to drop the question on the Discord, and I will check the Discord just normally. If I have any questions, I will just answer as soon as possible. So yeah, so I'm probably gonna end this Zoom. I'm gonna stop recording, and thank you for coming. And I just good luck on your midterm. Just don't be too nervous, because you have 2 more days that you have 2 more days than Meta 24, because Meta 24 have their midterm tomorrow while you're off Thursday. So you have 2 more days. And another tip. So if your registration call me up, it's just at 6 a.m. So this is when the registration starts. So if you register all your classes on Friday or so this week, just make sure. Well, I just make sure to wake up early if you want to get something that all the classes you want. Because some classes they're spot on very fast. Okay. I will stop just share my screen, and thank you for coming, and have a great night. Just good luck on your midterm. Don't be too nervous. I trust you can do well on the midterm. Thank you.